So as we move into 4 Toolbox, what we want to concentrate on is the higher level functions that we're going to see. Specifically, the shapes of those functions. Now, we've already talked about the quadratic function, the x squared function, but the good news is we're going to be able to extend that definition out a little bit to cover some of the other functions. So the first function we want to talk about is going to seem very similar to the x squared function. It's called the x to the even function. So we see x to an even number. You know, our old friend squared is definitely one of those even numbers, x squared, but x to an even number. And in fact, it's going to be a positive x to an even number is the first shape we're going to talk about. And it's going to look very, very similar to what we've seen before. And that shape is basically a U. The U. So we've seen that before, but now it really extends out to anything to an even power. So that whether that means it's x squared or x to the 4th or x to the 6th or x to the 68th, we're going to see this shape going with it. And what you're going to see over here as well is another shape, x to the even once again, but this time negative, we've also seen before. It's going to be the parabola-like shape going down. And again, that's going to extend out to anything that is even powered. So again, 2, 4, 6, 8, etc. That's negative in the front there. Now, one thing that I use to help me try to remember these shapes is a picture. And for each of these pictures, it's really a strong man. So let me bring in each strong man here so you can see what that looks like. So as you can see in the strongman pictures, the up one, the up parabola, kind of mimics this part of the strongman lifting something here, showing off his big biceps. And then our negative one is the holding up the barbell, but the barbell is so heavy that it bends down for this thing here. So I call it the strongman position, either up or down, and I think this helps give that impression. Moving on, the next shape that we want to talk about is the positive x to the odd power and the negative x to the odd power. So we have the positive x to the odd, and then we're going to have the negative x to the odd. And odd, of course, being 3, 5, 7, 9, etc. 1, even though it's odd, does not count as part of this set of things. All right, so for the x to the odd, what we're going to see here, get our Cartesian coordinate system in first, is it's kind of a funky shape in that it sort of mimics the parabola coming this way. Then once it hits the origin, it makes a turn, and it comes down this way. And the odd is very similar to that, except it's in reverse. And that it starts here first, comes down once again through the origin, and makes a turn and goes this way. Now, obviously, my drawings are not as great as the books. If you look on 4 Toolbox on page 420, you're going to be able to see the better looking drawings than mine. But I like to call these the disco shapes. And so let's bring in those discos so you can associate these shapes with that particular dance style and genre of music from the 1970s. And so now we can see that the disco shape comes in and that these really are associated with that disco shape. If you look at this one here, we've got the shape right here of our x to the odd that's positive, and right here with John Travolta's arms in Saturday Night Fever, the shape of x to the odd that is negative. So that's why I call it the disco shape. And again, it helps solidify it in my mind anytime dealing with an odd function that I'm doing the disco basically. And moving on again, now we have the square root shape, and really it's not even a square root, it's more of an even powered root kind of shape here. So the radical that we see, and normally there's a number here. If there's no number, it's assumed to be 2, but let's just call this the even out here. So again, that's going to work for 2, 4, 6, 8, etc. And we have a positive one of those. And then over here, we're going to do it again. A negative one of those. Now this shape, that's our Cartesian coordinate system in here. This one starts here right at the origin and then just kind of goes up and over. For the negative one, very similar, except it's going to go the same direction, but it goes underneath. And so one goes over the top, the positive one, and one goes underneath the negative one. The way I try to remember that is if it's positive, positive realm is above the x-axis, and negative realm is below the x-axis. So positive and negative on that. Now we have to have a shape that goes with this one too, and in this case, it's our friend the Karate Kid. If you've ever seen the movie The Karate Kid, about a young man who moves to California from New Jersey and then gets picked on by some bullies and learns karate to fight back. It's a great coming-of-age story. They remade that movie in the 2000s, but it was originally made in the late 80s and early 90s, I believe, of those movies. But we have the Karate Kid shape, so let's bring that one in. As you can see, the Karate Kid is now on the screen, and right here we see this is the positive square root of x up here with this arm, and right down here is the negative square root of x with this arm, hence why I call this one the Karate Kid. So again, trying to give it something to solidify this in your mind when we start talking about these shapes. And don't worry, we're going to have a one screen here at the very end. We're going to put all these shapes together so you can see them all at play, and we'll re-go over these one more time. The fourth in our shapes may be my most favorite, and especially when it comes to dance moves. We talked about that the x to the odd power was a dance move, was the disco move, if you will. And so is the radical that is an odd root. So if we look at this one here, we're going to have a radical again, except this time it's going to be odd out here. First we're going to have a positive one, and then once again we're going to have a negative one. And this one also comes from the 80s as well. It was a great dance and a song that was sort of made famous by the Bangles. It was called Walk Like an Egyptian. And so this one has a piece that goes like this. Looks a lot like the square root of x part of it. Then the second half comes down this way, like this. And the negative one, basically, again, is the reverse of that. So it starts here, kind of goes like this, and then comes back here and kind of comes down and sweeps that way. So this is the Walk Like an Egyptian. If you don't believe me, let me bring the picture in so you can see it. Now the pictures have come in. We can see we have the Walk Like an Egyptian this way, right? That mimics the shape that goes on right here for the positive radical of x to the odd. And of the negative, we have this shape right here, and again mimics from the arms of the Walk Like an Egyptian. So two dance moves for odd functions and two non-dance moves, maybe even two strong moves, you might say, for the even. Are you detecting a theme yet? Maybe. We'll have to see when we get it all together at the end, but there's something I think we're headed towards. On to the final shape that we want to talk about here in the 4 toolbox. And our final shape is the absolute value of x. We talked about the absolute value last class that we had as a live class, and I told you there were 5 rules when it came to absolute value. These really aren't the rules that we're going to talk about, but this is the shape of what absolute value looks like, so that when we know what it is when we go to graph. So the absolute value of x looks like this, the absolute value of x, and of course one's going to be a positive, just like we've seen, and one's going to be a negative. Now, the absolute value of x should remind you of another shape that we've done, except this one is a little more hard in nature and less curvy, and this is the V, is what it looks like. So it's a V that goes up here, and for this one here, it's a V that goes down. Now, a lot of people like to think of these as the olive oil of graphing because it's very straight and narrow and not very curvy at all. And that's not a bad way of thinking it, but I like to think of it more as the YMCA, another dance move. Let me bring those shapes in. I've lovingly brought in the Star Wars stormtroopers doing the YMCA in this particular case. And if we look here at the lead stormtrooper, the guy doing the Y, we can see that this is the positive absolute value of x. And in this gentleman here next to him, we can see that it is at least half of it on either side of it really is the negative absolute value of x. I've also gone ahead and brought olive oil into the screen, and as you can see here, she is sort of the epitome of these graphs. Again, she's long and narrow and straight and not very many curves to Olive here, even though this picture, she seems to be kind of curving her body. But if you were to look at her body, she's not very curvy per se. So now let's bring them all together so we can see that all of our shapes side by side and talk about any common themes and things that we see with those shapes. So here we are, we bring it all together and we have the whole palette other than our absolute value of x. But when we look at it here, right, we see the top is our even values and the bottom is our odd values. We start with the strong man, that is our x to the even power. Positive with the fists up and negative with the bar bending down. Then we move down for the odd function, x to the odd function right, that is the disco maneuver. So you can see when it's positive, the right goes up and the left goes down. When it's negative, the left goes up and the right goes down. You know, one trick I use to remember it in my own head is that positives is positive up and negative is negative up, as in which side of the x-axis is up. Then we move to the top right here, the Karate Kid maneuver. The positive is up and the negative is down. Once again, positive up and negative down. Then we move down to the odd rooted function. The walk like an Egyptian. Once again, the positive is going to the right. The negative is going to the left. So another good way to remember that. And then finally, I put a picture of my celebrity crush on here, simply because I want to remind you that these graphs should be curvy. Much like Ms. Minaj herself, the graphs should be of a curvy variety. And now to end our exploration of what the shapes look like, once again, we see our absolute value of x. Positive goes up, negative it goes down. Much like our x squared graph that we already talked about, where if a was positive, it went up. So positive up, except this is a V and not a U going up, and it goes down if it's negative in front. And our friend Olive Oil there, Popeye's girlfriend, remind us that these indeed are straight lines and not curvy lines at all.